Hi, my name is Richard Robertson. I'm an aspiring physicist. I am unofficial right now. I'm trying to go back into college in order to study physics and get a PhD in physics. I dream to become a theoretical physicist that teaches in a university or does theoretical physics as a day job. I wanted to introduce my theory about some reoccurring numbers in nature. It's very simple, but for some reason I haven't seen anybody else on the internet or in person or in the books that brings up this notable appearance of the number 3 and 1. The first example I will use is the 3 dimensions of space. Now, this is all theoretical stuff, and none of it's really proven fact, but it's enough to give a thought. If we could theorize that 3 dimensions of space actually exist, and that 1 dimension of time exists, we could assume and theorize that as far as the hierarchy of what dominates control and forces and law, etc., are the dimensions of which all the fields energy exist in, which in this case we are theoretically supposing that 3 dimensions of space and 1 dimension of time exist separately as two unique dimensions. Now, I don't know where they came from. I don't know how they exist, but I do know that they're stable and they do exist accordingly enough to be an experience for us. Now, the most important thing in my theory is that this ratio keeps showing up in all of physics, all of science. Now, I'm just going to bring up physics, a known knowledge to me that has this 3-to-1 ratio, and I'll explain why it's so important along the way. We also have 3 laws of motion, 3 laws of Newtonian motion. There is one thing that helps us understand and utilize more effectively the 3 laws of motion, and that's calculus. One form of mathematics, which is calculus. Now, it's very interesting. 3 laws of motion, 3 laws of space. We also have 3 quantum mechanics. Now, I like to call them 3 new ways or quantum ways to move, because they do displace themselves. So we could generally call it movement. And it's not Newtonian movement, it's quantum movement. But for now, we'll stick to the classic quantum mechanics. We do have equations, which is still math, just like Newtonian motion. We have calculus, we have quantum mechanics, and the math behind that. For now, I'll just put math. But it's still true, even though we don't have a solid foundation of math, in order to properly understand quantum mechanics well enough to even begin to fathom as to what's really going on. I will give more examples. There are 3 energetic forces in nature. One of them being the strong force, the second being the electromagnetic force, and the third being the weak force. Gravitation is not to be seen as an energetic force, as per Einstein has theorized that it is merely an effect of the dimensions of space and time and the curvature because of matter and energy bending it. However, we still have mathematics to understand the 4 fundamental forces of nature, and the 3 energetic ones and the 1 classic, gravitation. That's very interesting, because if we just took the 4 forces alone, we could separate gravity, because the energetic forces cause gravity. And it's very interesting. The forces alone do not, but the energy and the mass do. I apologize for me saying things that weren't technically correct. There's another example, and that's the atomic particle. The atomic particle has three main parts, besides all of the other subatomic particles that are included in the atomic particle. There's the electron, the proton, and the neutron. And those are three main parts. Though the proton and the neutron, they are actually a collection. They're hadrons, a specific class of subatomic particles. They're not like electrons because they contain multiple subatomic particles in order to exist. But the most interesting part is that you will not find three quarks and a simpler number other than a meson in an atomic particle that is stable. What is interesting is that the atomic particle at its most stable point will consist of three main subatomic particles. The hadrons do not separate and remain stable enough in order to consist of only one quark. Their most basic foundation is consistent with three quarks, and it's very interesting. But the three atomic particles, electron, neutron, and the proton, have one specific unique property, and that's the fact that they can change in amount in all three of the subatomic particles. So that means they have one in which this is theoretically infinite in ways it can exist. So just to review, I would like to show you, okay, maybe you can't see it on my camera, but I'll just state it. 3 dimensions of space, 1 dimension of time, 3 laws of Newtonian motion, 1 form of math, calculus, in order to understand. 3 quantum mechanical movements, and 1 form of math in order to understand and utilize. 3 energetic fundamental forces of nature, 1 gravity or math in order to understand it. We have 3 subatomic particles and 1 infinite ways it can exist or combine. What's very interesting is that vortexes also have this 3 number inside of it, and it is one of our ways in order to create very, very high energy states with a vortex. Though it is not the most energetic, it is one of the most simplest and easiest. The ratio is somehow known to be 3, 6, and 9. I do not know a lot about it, but if somebody could inform me well enough in order to properly understand vortexes and the importance of 3, 6, and 9, I would very much appreciate that. Now, I would like to ask anybody that can point out to me something in nature that doesn't have this 3-to-1 ratio, because I can't seem to not find it. If I look on, and if I draw, if I draw this diagram of the main subatom, the standard model, I can do it in a particular way which can visualize the ratio of the 3-to-1. So I would just over here.